Hello everyone and welcome to this lesson where we are going to get our hands dirty. We are going to code together a very simple tool, but I think is something quite useful, but it's going to give you a good introduction of working with Python in Houdini. So here's two things. If you don't have much experience with Python, if this is the first time you're diving into Python and you're learning Python, my recommendation is before you start this class for you to watch all the other lessons where we talk about working with the core concepts in Python. So the variables, working with lists, with numbers, all of those videos that are focused on the core concepts. Watch that. You still be able to follow this lesson because I'm going to explain a lot of the steps I'm taking, but some of the things may not make sense if you haven't watched those videos. Then, if you already have some experience with Python, then definitely I would recommend to make sure you watch the lesson where we cover working with the Who model. That way, you'll have a better idea what we'll be doing here. But this first lesson is going to be very simple. Is going to be a step by step. And if you already have some experience with Python, it may be a little bit boring because a lot of these things you already know. But I think it's a good introduction for everyone to be on the same level. So what are we going to do? Well, a lot of times in our work in Houdini, we have to bring assets from other software. So for example, from Maya, from 3ds Max, from Blender. And if you have to in the object network, you have to bring a geometry, and then inside the geometry, for example, you have a file, and then in this file, what you do is you open a folder with the files, right? And then you'll see that you have to open one by one, and then you need to apply, for example, if you're working from Maya, you need to apply a transform, and then add a scale, so 0.1. And then this you have to repeat again. So it's true that you can copy this, but then you have to select chessboard was done. So let me bring the knight white and then do the same thing and then copy and repeating, copying and repeating. And this can be time consuming. I mean, if you have like 2 or 3 files, it's okay. If you have more than that, it starts to take some time. And particularly in the production environment, there are situations where the files aren't as simple and straightforward as these. Sometimes you have files with very long names, and it becomes difficult to read and difficult to understand what you already brought into Houdini. So this tool is a very simple tool. All the tool it does is asks the user to select a folder or select a bunch of assets, and then you bring those assets. And the setup that we have here is going to do it for you. And then after that, it's going to bring merge nodes, and it's going to set this, and you'll have everything inside correctly. Okay, so this is what it's going to do. And then it's also going to take into account that if you are working with the Alembic instead of the file, it's going to load the Alembic throughout the Alembic node, so something like this. So one of the first things I like to do is to create step by step what I need to do. So that's why I have a clear picture of the steps that I need to take. And so let's start by saying first of all, we need to ask the user for the files. So this is our first step. Then we need to create a geometry node. Then inside this geometry node, we need to create a file node for FBX and OBJ or even the BGO. But if is an Alembic, we use an Alembic node, an Alembic loader. Then we apply a transform and set the scale to 0.01. And then after that, we add a material node just in case. And then after that, we just add a merge node. So this is what we need to do, right? And this gives a clear picture of the things we have to do. So where do we start? Well, I always like to start with importing the Who model. I know that by default you don't need to do this. It's a safe net for you because sometimes when you're testing your code and something breaks and you're going to run the code again, you may get a warning from Houdini say, "Hey, I don't know what this Who model is," and that's because it feels to me that something breaks, the connection breaks, and Houdini suddenly in this Houdini session model it doesn't know what the Houdini model is. So as a safe net, I just bring the import who, and that way it fix the issue. So next step is we need to ask the user for the files, right? So how do we do that? Well, if I go here to the contents, I'm going to show you where you can find all of this information. We are going to use a model which is called the Houdini UI for user interface. And you'll see here that we have access to all of the user interface related functions. We have things for pen layouts, but the things we want is the scripted UI. So in the scripted UI, we see I have a couple of options. We can display a confirmation message box. We have, for example, a display message. We can read input from the user. And this is the one that we want. We want to select the file. So what we need to provide? Well, we need to provide everything here is like none, none, false. We need to provide the file type, and that's it basically. It's usual perhaps to provide the start directory. You can provide a title, and that's what we're going to do. So how will this work? Well, first thing that I'm going to do, just going to bring this here, and I'm going to create a variable. And I'm actually going to create a comment say I'm going to declaring variables. So this is going to help us to start to block our code. So what I want is I want to select the directory where I want to work. And then I'm going to use the assign operator. And then in front of it, I'm going to start with a who model.ui. And I'm going to search for the select file. And then when I open the parentheses, I have the information that I need to provide. Maybe it would be a good idea to start with a directory, right? So we just provide some way for the user to have access to a specific folder. And one way, perhaps the best way to do that is just assume that where we have the file saved, it's going to be close enough to the folder that contains these assets, let's say. So how do we have access to that information? Well, if I go here to help and I go to about Houdini, and if I say show details, making this window a little bit bigger, and I scroll down here to the variables, I'm going to get to one, which is going to be useful. And that one is the heap, right? So heap is going to provide me the path where this file is saved. So this is what we need to use, the $heap. But then we have an issue because what's going to happen is that Python doesn't know what $heap means. It doesn't understand what that is. So what we need to do, we need to use something which is called expand string. So if I go here and I say expand string, you'll see this is a method from the who text. Yeah, from the who text model. And the expand string is this one here. Yeah, this one here, which you provide a string and is used to expand global variables in the expression. And now you may be asking, how do I know this? And the answer is Google search, because unless you read this documentation, it's sometimes difficult to know where these things are. So if you type something as like Houdini Python, how to work with the Houdini variables, for example, you eventually may find something that is going to point out to this information. And then my recommendation would be for you to do something that I have, which is a database where I store this information. So it becomes my own search results, and that way if I need to check something, I'll go to that database that I have, and I can find this information way quicker than if I go to the Google search. But definitely, a lot of the things you are going to learn that way. Someone went through the same process as you, posted a question on a forum, and then it got the answer, and then the answer worked for that person is going to work for you. So getting back to our codes, we are going to use the expand string. So for that to work, I'm going to create a new variable. I'm going to call default directory. And then here, I'm going to bring the who.text. And this gives you access to all the methods. So what I want is expand string. And inside, I need to provide a string, right? So what I'm going to provide is the single quotes and say I don't want the $heap, and then close with the parentheses. And now I'm going to introduce you to your best friend when you are coding. And the best friend is the print function, because the print function is going to provide us an idea what is happening and if things are working. So what I'm going to do is I'm going to print the default directory, which is getting this expand string. And then if I just move this here and I click apply, you'll see here on my Python shell that I'm getting exactly what I need. I'm getting the path to where this file is saved. So then what I can do is I can go back to my select directory, and let's go back here on the help to the who.ui so we can follow what we were doing. And if I scroll down and go to the select file, yeah. So what we need to provide is the start directory, and I can just copy this default directory here, and this is going to give me the path. So now the next step is I could provide a title, so it doesn't hurt, title. It's going to be equal to select the files you want to import, something like this. And then next we have collapse sequence. We don't need to worry about this. And then this is the next one which is quite important, which is the file type. And then we need to provide what file type we want to select, because if it's any, then anything that's inside that folder is going to be visible to the user. And this could cause some issues. So for example, if you have image inside, or if you have another Houdini file inside, the user by mistake may be selecting everything inside and just causing some issues and crashing the program. So what I'm going to do is I'm going to make this window a little bit bigger. And here I'm going to put a comma. So between any one of these parameters, you put the comma. And what I'm going to say is, so file underscore type. And then what I need to provide is the who.file type. So who.file type. And then when I put the dot, this gives me a list of possibilities that we have. So you'll see you can just select the Alembic files. You can go and just select a directory, and an FBX. But because we are working with multiple file formats, what I'm going to use is the geometry. And for you to have access to this information, if you go inside the select file, and if you go here to the section where we talk about the file type, and click here and open on a new tab, you'll see this is going to another web page. And it should go to another web page. So no, let me try this way. Okay, cool. So file type model, and you'll see that we have a list of the things that we can load. So Alembic files, FBX, USD. So where do we want to use is the geometry, because the geometry is going to provide everything that we need. So if you go back to our select file, we have the file type, we have the pattern can be none, and then we have one which we actually need, the multiple select. So by default it's going to be false, and what this is going to do is the fact that by default you are only able to select one file, and we don't want that. We want to select multiple files. So another comma, and I'm going to say I want to work with a multiple select, and instead of being false, which is the default value, I want to be true. And then I close with parentheses. And this is everything that I need. And just to make it easy to read, what I'm going to do is after the comma, I'm going to create a new space and press the tab key until I get here. and do the same thing here. And now this will become a little bit easier. Just again, like the tab here. There you go. This will become a little bit easier just to read, and you don't need to just keep stretching the window to see what the code is. So if I click apply, you'll see that's great. We have the default directory where we have the file saved. So that means we can just select everything. So if I click everything, accept, and that's it. Well, nothing happens. And why? Well, because now this select directory, this variable, is storing all the information that we selected. So for us to see, again, print is your best friend. So I'm going to copy this, paste it here, go to the same process, apply, just going to select and click accept, and then you'll see here on the Python shell tool that we get a very long list. But now the question is, what type of data are we working with? Is this a list? Is this a tuple? Is this a dictionary? So for us to know what are we working with, we can use the print function again, and then we're going to use the type function inside. When you open parentheses, you put the variable that you want to check inside, you close with parentheses, and now when I click apply, again, just going to select one just for the sake, you'll see that I'm working with a class string. So that means we need to pick up these strings. This is a very, very long string, and we need somehow to divide this string into usable data. And we can do that by using the split method. And I can do the split by using this semicolon. So that's what we are going to do next. So we are going to have access to this information. So to do that, what I can do is I can just select directory again. I can use the same variable. So what this is going to do is this is going to override the previous information inside. But that's completely fine because I'm going to override with a list. And then if you remember working with strings, what you need to do is you need to use the split method. And then the split method, you open parentheses, and inside you're going to provide what character you're going to use to split the string. So you start with the single quotation marks, and I'm going to use the semicolon, close with the parentheses. And now if I print this, right, I'll give a couple of lines here, click apply, just select a couple of them, and you'll see that now we have a list, and then this type is confirming yes, you're working with a list. And now that we have a list, what we can do is we can just loop throughout this list and start doing what we need, starting bringing these assets into Houdini one by one. So how do we do that? Well, what I'm going to do here, just going to delete, and to work with the list, I'm going to use a for loop. So what is the next step? Well, the next step is, first of all, just remove this. We ask the user for the files. We have that information. That information is stored inside the variable. That's fine. So now we need to create geometry nodes. Okay, so how do we do that? Well, the easiest way to create this geometry node is, first of all, to establish what is the context or the network we are working at. So the way I like to do that is just by creating a variable called obj if I'm working, for example, in the object network. And then what I'm going to do is you're going to use this function called who.node. And this function, what is going to give us in return is the node object. So the object network, it's considered an object. And then with that, we have access to all the methods to be able to manipulate everything inside this object network. So the way you define that is by providing a path. So the path is going to be the single quotation / obj and close with a single quotation with the parentheses. If you were working, for example, in stage, you would replace the obj with stage, and then you would be defining the path to that network. But we want to work with obj, that's what we want to do. And now if you want to check what kind of class is used to create this object, what you can do is you can use the print function and do the type, and inside you're going to put the variable, and when you click apply, it's going to tell us here that we are working with the class who.opNode. So if we go here and if we search for the who.opNode, you'll see this is a class, and this class is a child of the who.node. And then inside here, we have everything that we need in order to work in this context. So you'll see, again, my recommendation would be for you just to go through the documentation and see what is possible to create. Obviously, this is a little bit abstract because sometimes you see things that you don't know you need, but sometimes there are things that pop up and you're like, oh, this is interesting. Maybe this is something that I could use for another idea that I have. So I know that inside here, we have a method which is used to create a node. And sometimes you can use just a filter just to see if like what are you looking for is available. So if I start typing create, maybe is what I need. So create, and then if I create digital asset, this is not what I want. And then who.node, create node. So this is what I want, create node. So this is a nice way using the filter to try to filter something that it could be useful for you. So create nodes. This is a method that we can use, and it's quite simple to work with. Sometimes even inside you have a snippet of code that tells you how to use this method. So all we have to do is, well, similar to what we're doing here. So obj is equal to who.node with obj path, and then we just say obj.createNode. So that's exactly what we're going to do. So we're going to say that we want a new variable. It's going to be geoNode. It's always good to put this inside variables. And then very easily, we're going to make reference to the obj variable. Remember that this variable represents this object. It means that then we are making an instance of this hop node, and in that way we have access to these methods. So now I put create nodes, and then what is the information we need to provide? Well, if we go here, we'll see that the information we need to provide is the node name. So the name of the new node. And how do we know that name? Well, an easy way is by dropping the node that we want to create. And then if you go to the node info, you'll see here on the top that we have the object we are working with. In this case is the geometry object. And between the parentheses, we have the name of that object. So what we have to write here is geo. So between quotation marks, I'm going to type geo. And then after that, I don't need to provide anything else. Actually, everything else is just has just default values. But one thing I like to do is just giving a name to this node. So I'm going to do that by node underscore name. It's going to be equal. And I'm just going to say something like temp geo, and this will be useful because we may just want this geometry node to store temporarily all this geometry, and then we're just going to copy to a specific position. This actually reminds me of something, which is the fact that usually all these scripts, they start very simple. And then when you share with other people and people start working with it, they start giving you suggestions. You also think about things you could add to the script, and then the scripts start to evolve and start to get more complex. So initially, don't be too concerned in terms of trying to cover everything that could happen. Like, for example, I'm thinking that we could have a pop-up window and say what you want to call this node, or saying where do you want to import these nodes. But for now, just let's keep it simple. Let's see how it works, and then we can start building on top of this script. But at least let's say the skeleton of the code, it's done, and then we can improve it. So don't get too concerned about getting like a perfect script, because that doesn't exist, and there is always room to improve. So something just to keep in mind, don't get very anxious about getting everything perfect. So getting back here, we have node name is going to be temp geo. That's perfectly fine. So this is the process that we need to create a geometry node. And then inside is where we're going to create everything. So just for the sake of demonstration, what I'm going to do is I'm going to comment out this. so I don't have to open again the folder. And I'm going to click apply and see if this works. And it works. I have a geometry node called temp geo, and it's perfect. It's working. So what do we have to do next? Well, inside these geometry nodes, we need to create a file node for FBX, OBJs, and so on. Let's worry about the Alembic later. So how do we do that? Well, this is a stage where we need to start to loop through the assets that we have stored in this list here. And with the information inside the select directory, we are going inside the geometry node, create a file node for every single one of these assets. So let's start with that. And for that, we need to loop through this list. And you can do that with a for loop. And the for loop, the way it works is, if you don't know, is you start with a for keyword, and then this is one of the situations where the variable names could be just a single letter. Sometimes people use X, sometimes they use I. I personally like to use something a little bit more descriptive. So let's say I'm going to call item. So for item in selected directory, what do we want to do? Well, let's now print every item that we have inside, okay? So just going to give it a little bit more space here. In the Python shell, apply, select all the files, and accept, and there you go. So what we have here is the path that we have for every single one of these assets. And this is the information that we need to start to tweak in order to be able to create the nodes and create everything that we need. So first thing that we need to do is we need to extract the name of the asset. It's going to provide us, first of all, the name that we have here, but it's also going to provide us the extension that we're working with. So this is very important. So what we are going to do is, inside the for loop, we are going to create a new variable. I'm just going to call asset, and this is going to be equal to item. And then remember that inside the list, so this is the information we have inside this list, but this is still a string. So being a string, it means we can use the split again, and this time what we can use as a character to split the string is the forward slash, and that's what we're going to do. So if I go to this, and then I do the forward slash and close with the parentheses, and now if I print asset, you'll see that we have something completely new. Just going to select just a couple of and click accept, and you'll see that now this asset variable, instead of having a string, it contains a list, and the list provides us all the information that we have on this path, including the last item is going to provide us the information that we need to get the name and the extension. And remember that we're working with lists, it means we can work with index, and the asset name is always going to be the last index. So that means we can, for example, here put the square brackets -1, and now if I click apply and select a couple of these assets, you'll see that we get exactly what we need, the last item in this list. Still, there is some extra tweaks we need to do, because now we have the asset name along with extension, so we need again to split this information in order for us to have access to what we need. So what I'm going to do is I'm going to create a new variable. I'm going to call object, and inside object I'm going to say that I want to pick up this asset, which is a list, and then I want to grab the last index. It's going to be -1, and then I'm going to split again this string. And the way I can split that is by using the dot, right? This is what makes the separation between the name and the extension. So again, open parentheses, going to say I want to work with the dot, close, and if I print the object, and I know it can be, for someone who already knows Python, this can be a little bit tedious because it's like printing everything, but it's a great way for you if you're learning, just to make sure if things are really working the way you're expecting. So if I select some assets, and you'll see that now object is a new list, and this list now has the index 0 is going to be the name of the asset, and the index 1 or -1 is going to be the extension. And this is perfect. This is what we need to start working. So let's go to the next stage, which is creating the nodes. So we need to create the file nodes. So what are we going to do is I'm going to start with a new variable called new file loader. And what are we going to do now? Well, we need to create this file inside the geometry node that we're going to create. So what I can do is I can access this geo node. This geo node represents this object, the geometry node. And the same thing that we did where we say create node, I can do the same thing with the geometry node. So if I copy the geometry node, remember this represents the geometry and is making an instance of the class that was used to create this node. So that means that now I have access to the methods related with this class. And just for the sake of explaining how the Houdini model works, just so it's clear, what I'm going to do is I'm just going to comment this out, and I'm going to say to print type geo underscore nodes, and just comment this out, and I click apply. Oh, there is an error here where, oh yeah, I need to close the parentheses. So if I click apply, you'll see that the geometry nodes that we have here is part of the object node class. Okay, so if you go to the object node class, so who.obj nodes, you'll see that this class is also part of the hope node. And if we go to the filter and search for the create node, you'll see that this is also inheriting the method from the who node. So that's how I know that I can use the create nodes and create more nodes if I need to. So let's go back to here, just going to comment this out, and same thing here, just going to comment this information and remove the print. We don't need that anymore. So geo node represents this geometry node that we have here. And what I want to do is I want to create the node, and the same thing. Just going to delete one of them because we keep creating them but not deleting them. Cool. So inside, I need to create a file node. So this file node, if we go to the node info, we'll see that it's called file. That's great. So that means I just need to put here file. And now the next thing that I can provide is a node name. I don't have to, but I like to keep things organized. And since we're creating this name for free, then why not keeping things all tidy and clean? So what I need to do is I need to create nodes underscore name, right? Just like double check node underscore name. And then we need to provide the name. Now, what would be a great name for a node? Well, what about the asset name? And how do we have access to that information? Well, in the object, if we ask for the index 0, it's going to give us the name of the asset. So that's something we can do. We can do object and then use the index 0, and then when you close, and that's it. That's just going to create a node, a file node, and it's going to change the name to the asset's name. Now, it could be the situation someone will say, well, this is not very descriptive, it could be confusing down the line. So one thing that you can do is you could create, for example, another variable and say it's called object name, and this would be equal to object index 0, and then you could create another one called object underscore extension, for example, and call it objects and then -1. So you could do something like this, and then instead of using the object index 0, just copy the object and name inside. This is totally fine. Or for example, if you don't want to have more text, what you could do is just could add, or you can write something like object 0 is the name, object -1 is the extension. So when you're reading the code and you're just reading through, you get to this comment and say, so object 0 is going to be the name, and when you get here, if you have something like this, then it's clear what you're doing. And the same thing, like nodes underscore name is equal to object. It really explains what's happening here. So both options are completely fine, but we could just keep it object name as well. I'm going to keep it the object with the index just to save a couple of lines. So this is going to create the file that we need. But then what else we need to do? Well, we need to load the file, and that means that the geometry file needs to have a path to the correct asset. So how do we do that? Well, to do that, we need to work with the parm class. So here, you'll see that the parm class, what it does is related with the parameters in the nodes. And this allows you to manipulate those parameters, checking the information you have there, set that information. And if you scroll down, you'll see here in terms of values, for example, you can evaluate the value that's inside. You then can also set that value. We'll have a lesson where we dive a little bit more into working with the parameters. But for now, what I'm going to do is I'm just going to create a new file node and show you how this class is going to work. So if I open here a new Python shell, then I'm going to create a new variable, new var. It's going to be equal. Just drag it over here. So now this variable represents this object. And the way you have access to this information is by typing new underscore var, and then dot, and you do parm, and then you want to specify what is the parameter you want to check. So a way to check the name of the parameters is by going to the node you want to check. And then, for example, if you hover here this name, the geometry file, you'll see that we have access to the name of the parameter. And in parameter, you see the name used to identify this parameter. So in this case, it's file. For example, this one for missing frame is also missing frame. Cache frames is going to be cache size. Sometimes they're quite obvious. For example, file mode is going to be file mode. Other times they may not be that obvious, like cache frames is going to be cache size. So what we need to put here inside this, let me get me back to the Python shell. So what we need to put here in this parm, the name that we find here, so file. So here I'm just going to put file. To see the information you have inside here, we're going to use the eval. So eval, and this is going to tell us that the information inside is default.bgo. So if you want to change that, so instead of eval, you're going to use set, and you just put whatever you want. So for example, if you put $hip and close, it's going to change to $hip. Obviously, it's going to cause an error because this is not a path, but you see how it works. This is how you evaluate the parameters and then you set values. Obviously, later we're going to dive a little bit more into this class and see what you can do with it. So getting back to our codes, this is exactly what we need to do. And I'm going to then type file loader. So parm, I want to get the file. Close, and I want to set. So what I want to set? I want to set the path. Where do I have that path? Well, in the select directory, I have the list with all the paths, and the item variable that I created stores that path. So I could just use this item here, and this is going to give us the correct path that we need. And that's what we need to do so far. So if I just delete these, click apply, select one, accept, inside, and there you go. We have our file loaded. That's it. It's working. So what is the next step? Well, the next step is to drop a transform node. Because of the scale, most of the times you have to scale this down to 0.01. So we need to create this transform node and set the uniform scale to 0.01. I would say at this stage, if you want to test this, just stop the video and try it for yourself and see if it works and come back to the video. Okay, so what I'm going to do is going to call transform underscore nodes. This is going to be equal, again, I want to create this node inside the geometry node. So geo underscore node, I can just actually copy this here and avoid having to type everything from scratch. So geo create node, and what type of node we want to create? It's not a file. Go to the node info xform. Okay, so xform, and now the name could be object with the index 0. I'm going to concatenate these, putting a plus, open with a quotation, and say xform. And then, yeah, this is going to work. So next step is picking up these transform nodes dot parm, and what I want to change is the uniform scale. So if you hover your mouse over uniform scale, you're going to get that the parameter name is called scale. So that's what I'm going to do. Scale, close, set. Wait, see here, I forgot to close this. And then set. And what I want to set is a float value, so 0.01. And that's it. So now delete, apply, select, and there you go. We have the file, we have the transform, but we have an issue because this is supposed to be connected. So how do you connect this? Again, this comes with experience and some research, but what we're going to use is a method called set input. So set input is part of this class here, and what we want is the set input with the input index, right? So with the input index, we are going to provide an index, and we're going to provide the item that we want to connect. So for that, what I'm going to do is I'm going here to the transform underscore node, and I'm going to do it dot set input. And what I need to provide is an index. So the value for this connection here is going to be 0. So the first value is always going to be 0. So put it 0. And now I need a way to tell that the node that I want to connect is this file node. So how do I do that? Well, we already have a variable that represents this object. So all we have to say is just connect this object to this node. So new file loader actually is a variable that represents this object. So all we have to do is copy the new file loader, put it here, and then Python already knows that just needs to connect this node here. So if I delete, again, so delete, apply, select, accept, and there we go. So the next thing we will have to do is just set the display flag to the transform so we see it. And we'll do that, but not with the transform node. So next step is going to be creating a material node. And again, if you want to stop the video just to do this by yourself, will be a great exercise, because this is a good way for you to see if you understand what you're doing, find mistakes, because quite often it's by doing mistakes that you're going to learn. So we need to know the name for this material, and just let me guess, is going to be material. And this is something I love working with Houdini, is the fact that a lot of these things are going to be super intuitive, and it gets to a point you don't even need to check the names for nodes and other things, because it's quite obvious the name is supposed to be. So instead of xform, I'm just going to replace this with met, and using the same principle, I want to connect to the input 0 the transform node. So what I'm going to do is copy material node dot set input, and then index 0. I'm going to copy the transform node variable, put it here, close it. Let's repeat again. Delete this, apply, select an FBX, and there we go. We have our file node that's loading the correct file. We have the transform nodes, and we have the material, and everything is properly renamed. So this section is done. File node for FBX, OBJ, and BGO. This is done. Now we get to the, and this one is also done. Set the transform scale to 0. and add the material node to 0. So a lot of things were done in one go. So the next step is, if is an Alembic, we're going to use an Alembic loader. So this is where we start working with the conditional logic. So if something is true, we're going to do something. If not, we'll just do something else. And if you're new to Python, if this is something new for you, then I recommend to watch that lesson where we cover precisely this topic. So what we're going to do is we need to check if the extension is going to be Alembic. We're going to load an Alembic node. So we're going to load this Alembic node. And then after the Alembic node, in order to have access to the geometry, we're going to work with an unpack. And then we can just repeat the process and do this, apply a transform with the material. So same principle. So what I'm going to do is, inside this for loop, I'm going to put an if statement, and I'm going to say if object with the index -1 is going to be equal to ABC, just to keep a consistency with the single quotes, ABC, then we are going to do something. And then if this condition is false, so if it's not ABC, we are going to run this code here. Let me just select the correct code, just run this code. Okay, so that's why we have the else. So it's just going to run this. So what we have to do with the Alembic? Well, the same process, basically. All we have to do is load the Alembic node. So again, if you want to stop the video and do that by yourself, welcome to do that. If not, just watch me do it. So I'm going to create a new Alembic underscore loader. It's going to be equal to, just going to copy this here, just paste it. Alembic, it's going to be Alembic, yep, that's it. So Alembic, and the name is going to be the same thing. So then after this, what do I need to do is I need to set the file name. So if I go there, I can see that the file name is going to be file name. So just going to copy this here, just paste it, and then parm file name, and then set the same thing, just going to use the item. So this is what I need, and then I need to create a new unpack. Just call it unpack node, and this is going to be the same thing. So just going to copy this one, and the unpack, well, let me guess, it's going to be a call unpack. Yep, that's exactly that. So unpack, and it's just going to add more information to this string and say unpack. It's just for consistency, instead of double quotes, going to use single quotes. So that's it. And the next thing we need to do is connect this node to the Alembic. So set input is going to be 0, and I want to connect the new Alembic loader. So let's see if this works. I'm going to delete the geometry nodes. I'm going to click apply, select everything, accept, and now, well, it seems to be working. And I'm seeing an issue with some of these elements. And the issue we're seeing here, which it was working before, and now we're seeing a lot of these errors, has to do with something that happens when we select the information using the select file. And I noticed that, and I just left it, because this is situations where you are starting to expand the code and then suddenly something breaks, and you have to try to understand what is happening. And this one is not very easy to understand what's happening. But if, for example, if I select this one, you'll see that here on geometry file, we have a space. So if I remove this space and I remove the space at the end, you'll see that now the message is gone and we do have our file in. So how do we remove this? Well, the issue that we have is, like here you can see we have spaces. Now, if you remember correctly, with strings we have a method which gives us the opportunity to remove any kind of spaces we have after or before. So what we're going to do is we're going to pick up the item variable, and we're going to say the item is going to be equal to item, and then I'm going to use the strip, and this is going to remove the white spaces we have on the left and on the right. So now if I delete this and I run the code again, click apply, select everything, you'll see that now we don't have any issues. So this fixes the issue of loading the file, but you see that we don't have any Alembic files here. And the issue is because the white space that we are getting are making this condition false. Because this is going to read as ABC with a space, then it's just going to say, well, this extension doesn't exist. So everything is going to be loaded using the file. So what we have to do, we need to move this variable from here to here so that the item is clean, then it's going to be split, and now this is going to fix the issue. So if I delete this geometry, if I go back and if I select everything and click accept, now everything is working now. Where we have our Alembic files, we have the files for the FBX, for the OBJs. So do you see how a very simple mistake can just mess up with your codes? And I'm really happy that this happened because it shows how you can go back and see what was the issue. So just by moving this variable up, so the white space is going to be removed first before we do the split. It's just fixing everything that we have. Now, the Alembic, what we need to do is we just need to copy this information from here to here. And we, instead of new file loader, we're going to put the npack, and the transform node is fine. So if I delete this temp geo and I select now everything and click accept, go inside, Shift L to, and now everything is working as we expected. So the last thing that we need to do is we need to add a merge node. So how are we going to do that? Well, we need to add a merge node. That's fine. So we need to create these nodes. And the way we're going to create is just by using the merge. So we can do this outside the for loop. So we don't need the merge node for every single one of these items. We just need one. So what I'm going to do is here, just going to call merge node. It's going to be equal to obj create, and then I'm going to change to merge and just call it merge all, for example. So that's it. And now the question is, how do we add the input from the material to these merge nodes? Well, the solution is quite simple. We know that the first input is going to be 0, and then the second one is going to be 1, and then 2, and so on. So for example, if I connected this here, you'll see that we have the first input, and then it's going to be 1, and then 2, and so on. So what we have to do is we are going to create a variable, and I'm going to call that variable add to merge, and the value for this variable is going to be 0, right? Because this is the first index that we need to add. And then when I finish everything that I have to do with the if statement, what I'm going to do is here, just giving the correct indentation so it works, otherwise this is becoming part of the else. I am going to call the merge node that I created. So I'm going to say merge underscore node, and the same thing that I did here, for example, the material to set input, that's what I'm going to do, and say set input, and then the index is going to change. So it can be 0, because otherwise when you run this, you're just going to have the last node connected to the 0 position. And we don't want that. So what we want to do is we want to use this add to merge, and this add to merge is going to store the index. And you'll see in a second what I mean by that. And then the last node we're going to use is the material node. And I'm just going to run this just to show what is going to happen. So if I delete this geometry node and I click apply and I select everything, say accept, and this is not going to work because I made a mistake. And instead of creating the merge nodes inside the temp geo, I tried to create the merge nodes into the object context, and that the symbol doesn't work. So instead of saying obj, it needs to be geo node. So now when I run this again, and let's see what's going to happen, click accept. Now you'll see only one node is connected to the merge node. So that's not what we want. But we know at least that the add to merge is working. The value 0 is being used. So what we want to do is, after this merge node, we're going to tell to the add to merge node to increment his value every time it runs through the loop. And the way you can do that is with the plus sign and then the equal sign and put 1. And now what this is going to do is the first time the for loop is going to run, the value is going to be 0. But then the add merge is going to be incremented from 0 to 1. So the next time the for loop is going to run, the index for the merge node is going to be 1. But then the add to merge is going to be incremented by 1 and passed to be 2, and so on until it reaches the end. So now if I delete this and I click apply and I select everything and click accept, you'll see that now everything is connected to the merge node the way that we wanted. So that's the idea of plus equal to 1 is going to increment the value every single time, and that's how we can add everything to the merge node. So this is basically done. The only thing that would be quite cool would be the fact that we don't have to come inside and use the Shift L just to put everything together. So for that, to avoid that, what we can do is at the end of our code, we can just make reference to we can grab our variable geonodes, and we'll cover this later, but for now you can use a method called layout children. And what this is going to do is, instead of having to press the Shift L, it'll just do that automatically for us. So now when you go inside, everything is really nice layouts. So that's what we have to do. Now, before we finish, there is a couple of things I want to highlight, which is what if the user, instead of selecting something, just click cancel, right? Well, first of all, we still create a geometry node with a merge node inside, which is useless. But at the same time, we get the error message saying like, yeah, the list index is out of range. So how can we fix this? Well, we can fix this by bringing everything that we created so far. Just going to close this for now so we have more space. Just bringing everything that we have now and put this inside if statement. Now remember that the if statement only is going to run if the condition is true. So what we can check is if the selected directory is empty. If it is, then we can pop up a window and say, hey, you need to select a file at least. So what I'm going to do is I'm going to grab the code here. So we need the default directory, we need the selected directory, and then I'm going to put if, and I'm going just to say select directory. And this is the same as asking, is this valid? And then all these codes, just going to select and press the tab key to let me select this one as well. Select everything and then press the tab key to add the white space. So this is now part of the if statement. And if, for example, you'll see if I click apply, and if I don't select anything, well, nothing happens. So now we need an else statement just to say, well, it would be better if you select a file for this script to work. And the way we can do that is getting back again to our help file. And if you go to the who.ui, you'll see we have an option here for the display message. So we need text and the buttons, and that's basically what we need. So what I'm going to do here is inside this else, I'm going to say who.ui display message, and the text that I want is just going to be please check again, no valid file was selected. And then you put the comma, and then you need the buttons. So you're going to put buttons is going to be equal to open parentheses, and you put OK, close, put the comma, because this is technically a tuple. So now if I click apply, oh, and I need to close with the other parentheses. Okay, cool. So now if I click apply, if I don't select anything, it's going to say please check again, no valid file was selected. But if I click and I select accept, there you go. We have our geometry nodes. Everything is loaded correctly. Alembic files, we have the unpack, we have the transform, we have the material. Same thing for the FBX, for the OBJs. And then we have the merge node where everything is correctly connected. And that's it. That's a very basic tool, but I think is a good introduction to how to work with Python in Houdini. And on the next video, I'm going to highlight a couple of challenges that I want you to have a look and use that as a, let's say, as a homework for you to keep improving these scripts and make it more useful. So let's go to the next lesson.